Hi and welcome back to our look at X-Particles dynamics. In this part we're going to be looking at the XP4. Now this is a new addition to X-Particles 4 and it is a really tremendous modifier. It allows you to almost create your own custom modifiers within its bounds, within its sort of cellular grid. And it's sort of endless possibilities when you start layering it up with all the other things we already have in X-Particles. But for now I'm just going to be talking about just the FlowField. Because there's a lot to talk about. I probably won't get to everything that it can do, but I'll demonstrate the sort of the main features. So where do we find it? We find it in the usual place, of course, in the dynamics part of the XP system. And I'm going to add an XP FlowField. And you can see here, immediately we see something that looks somewhat familiar. We've seen this sort of shape before, especially in these sort of more recent ones like the cellular automata. It's a voxel grid. So we've talked about voxel grids before. This is divided up into cells, and then within these cells we actually have these lines. Because if you look here, we're not actually, if I go into the views here and I just frame up what we've got here, you can see there. Now they're only in the Z direction, so there's no sort of horizontal dividing lines, which is normally visible in the voxel fields. But we're not actually seeing the edges of the voxel fields here. We're actually seeing a vector. Now what's a vector? Let me go to the FlowField, and in the vector display, we have these options for displaying our vectors. And now I'm going to drop the transparency down to 0, just so that it's pure color. And I'm also going to make our FlowField only one cell thick, like we did with our cellular automata, because it was easier to sort of demonstrate. Oh, there we go, it's in X. Now, these vectors, I shouldn't call them velocity vectors, because they're not all velocity vectors. These vectors are pointing in a certain direction, and it's a bit hard to see which way these are facing at the moment, but if I go to vector display and I click two color vectors, what we see here is we see this red part and then it goes to the end, and you can see there's a little dot at the beginning of it. That is the direction essentially, so we're going from this color 2 to the color 1, and that's the direction they're moving. Now if I just turn it off just to show you what we've got in our system here, if I just press play, you can see our particles are just moving off on their own steam. It's a defined emitter, spacing is 40. Now the spacing is 40 because our velocity grid is also a spacing of 40. And you can see they're aligned with, they're overlapping with the velocity vector. So nothing's happening at the moment. Well, why is this? Because it appears that nothing is happening, but actually something is happening. And this flow field that we've just added is in a flow mode, a field mode called direction. And what it's saying to the particles is when you enter this cell, apply this vector with a strength of certain whatever it is. And it's only applying the vector to the direction of the particle. It's not adding any speed. There are different modes that we can add speed, but just to quickly demonstrate, if I rotate this, you'll see that the vector fields are moving off in that direction and the particles will follow that direction. And there we go. And we can have the particles start outside the field and move into the field. And away down they go. So that's the simplest way of understanding that, and even I could doodle over this just to drive that home. Oh, wrong object there. So we've got this particle that emits in here, but the voxel grid is actually here. So you can see here, this is a very bad drawing, but we'll, get the idea. And dividing each there. So each one of these is a cell. Each one of these is a voxel. And what we could do, we can actually draw the direction of each one of these just by based on the color there. And you can see it's pretty boring at the moment. They're just facing all the same direction. But if I change the mode of the flow field, click on the flow field, and I'm going to change the flow mode from default to random. And you can see immediately all our vectors are facing in random directions, completely random directions. And if I press play now, if I go to my 3D view actually, and I press play now, you'll see our particles are moving off in all sorts of directions. They're also leaving the field very quickly. So once they're out of the field, they're no longer being told which direction to go. I don't want them to actually leave the field, so I'm going to use this. I've already set this up. Got an XP limit here. I'm going to turn it on. And all that's doing is it's saying that we're going to completely limit the X direction. So even if the vectors are facing in the X direction, we won't have any movement there. So let's test that out, make sure that's working. Lovely. There we go. And you can see they can still leave at the top and the end, but we're getting a better idea of what's going on here. And so what is going on here? So if I push the particle through, and you can see we're getting this movement. Now, this one here is following correctly along here, and this one is sort of moving through these fields. And then when it gets into the fields, it might not look like it's being influenced by them, or it might not look like it's exactly following them, but that's because we've got this 10% influence. The flow field is only influencing them by 10%. And if I draw arrows here, we can see the direction of these, and definitely the direction of these is added up to bring all these particles up here. So you can see this particle down here started here. Well, it had a bit of influence down, but it also had some from the neighboring one up. And they do influence across. There's a bit of smoothing going on. So it's not just when one cell that has an influence. There's a sort of a small amount of inbuilt fall off. And so as the particle moves up, you can see it's following these arrows, and then this other one's getting caught by them as well. And then eventually it's getting told to go back up this way. And this, if you watch this particle here, it should kind of go up, follow that one there. And there you go. So that's kind of a crude drawing, but it just explaining the direction of these vectors. And that's really important to know for the rest of this part, because this is how the particles are influenced. They move into these cells. They are evaluating the cells around, and they're looking and they're going, okay, this one's pushing me to this direction, this one's pushing me to this direction. Balance out that direction and just apply it gently to the particles. And we don't have to apply it gently. We can, of course, apply it extremely. If I put the strength to 100, and you can see what happens here is these are all equaling each other out, or sort of essentially you're getting a motion. Oh, that's not a very good color to use. You're getting a motion that is resulting in a total sort of loop, and they will not be able to escape because they're all 100% influence. So essentially the particle can't actually escape. Ooh, I've gone back to below 100. And we can find a balance here. You can see they're getting caught at above 50, even below, and you'll find a balance. But the point is that we can change the influence of each of these cells. Okay, cool. So this is how I've demonstrated it in 2 dimensions. Let's have a look at it and how it works in 3. So let's make our grid bigger. And we can also, like I showed before, we can change the display parameters of our vectors because they're currently quite dominating. I just wanted that on so that we could see it clearly. But I'm going to increase the transparency. And I'm also going to reduce their max length. The max length, you can see, that's essentially a way of just displaying them in a sort of more, less conspicuous way. So I'm just going to reduce them down to something, I think the default is 75. Yeah, there we go. And it's still quite busy in there, but I'm just going to let the particles play through. Oh, turn our limit off as well. And we can see they're moving through the field and they are being given a direction. And then when they leave the field, they are off into the distance. Now I can do an action on them. Whilst we're on that, about leaving the field, we can actually kill the particles or do anything to the particles as they leave the field. And we can do that using an action. You can see we have an actions tab, and here it says actions on escape. If we had an existing action, we could add it into here now, but I can just use this convenient button, add action, and it takes us to our action. And if I just use editor display, for instance, and just to demonstrate what happens when it leaves the field, just to prove that the detection is going on, there we go. Can you see it changes it to a circle once they leave the field? But maybe we want to do something more specific. Maybe we want to kill the particle or freeze the particle. I think freezing it is probably the safest thing, especially when you've got trails. Freezing the particles it's going to maintain the trail. So I'm going to click freeze particles, and here you go. So we've got an action occurring when the particles are going to try and leave, and there you go, they freeze when they hit the edge, the boundaries. And you can animate your particles into the field as well, by the way, I should say. And press play, and you can see they come in, they're not being influenced by it until they enter the field. And then when they try and escape again, they're hit by that action. But you don't have to actually start the emission inside the field. Now, there is a caveat to that, and that actually leads me on to these next modes that we're going to look at. And if I go back to general, we can see this the field modes, direction, velocity, and acceleration. Currently, we're only applying a direction to the particles, and the speed is coming from the particles themselves. So if I increase the speed to 500, which is very high, press play, you can see they fly through the field very fast. If I apply the direction heavily, they'll try. You can see we're getting sort of glitching because it's going extremely fast and fighting against it. But I can get more detail into there. But if I take the emitter out, if I change the mode to velocity, which is a speed mode, and I go into our emitter and I take the speed off completely, this is now actually applying a speed as well. So if I actually drag this emitter out like we did a second ago, you'll see the particles aren't moving at all because they are outside of the field and there's no velocity being applied. But when I bring the emitter back in and restart the sim, you can see they're being influenced again and actually having velocity applied to them based on this strength and the speed value here. And it's the same for acceleration as well. So as it enters each of these cells, a acceleration value of 20 per second is being added to the particles. So you can see that will start to speed up and speed up and speed up. If we increase it too much, obviously it's going to zoom out of there. And yeah, this is just a different way to apply movement to your particles. And in fact, we can actually show this quite nicely. If you're just applying direction and you have 0 speed in your particles, which we have, and I'm just going to zero out our emitter. Let's hide our vectors for a minute. Sometimes, by the way, you'll want to hide your vectors because performance in the viewport can decrease if you have a really dense grid. Although we don't have too bad here, it's not too bad. So 3D grid, I'm going to make it 6 by 6 by 6, and then a spacing of 40 in each of them. And what happens when we emit? We can see the particles emit, and then they face a direction along these vectors, or sort of a blend between the cell vectors. And that's actually quite a nice way to visualize things. If I actually make this just 1 thick. Wrong. I keep hitting the wrong field there. There we go. And you can see actually this is where the particles are pointing. It's actually a good way. This is actually a nice way to visualize your velocity vectors or your vectors. Okay, so that's direction. But then if I applied some velocity, so go back to the general tab, hit velocity, you'll see it actually adds speed to the particles. And you get these beautiful sort of, it's almost like a curl noise in random mode. And you get some really interesting things going on. Sort of eddies almost in sort of fluid dynamics. Okay, so that's the different field modes. Now we get onto the really interesting stuff, which is actually all the different inputs for the flow that we can create. So how we create the flow. So obviously default, if I put the vector display back on, default is just going to point in the one direction, and it's usually Z+. So there we go. We could have that pointing off in that direction. Let's make our vectors very faint. There we go. And you can see off they go, whichever way I point the grid, or point the flow field, sorry. So that's default, pretty boring, I would say. Rarely used, to be honest. I don't find I use that one much. Random, we've just been dealing with, obviously, and that just sends our particles off in all directions. Do you know what? I'm going to change our emitter to a circle, and then we get way more particles. And you see the real beauty of this starting to take shape. And you can animate the emitter through, of course. We've got a lot of trails going on here. I think this is probably struggling. There we go. Let's just go for that. You're getting sort of really fascinating looking vortices going on, and it's like I said, it's like an advanced curl noise, and they're freezing when they get to the edge as well. In fact, we could change this freeze to a kill now. So I'm going to change the action to a change life. And you can see, because I've not got the trail on anymore, we can just have them kill the particles as they hit the edge. Back to the flow field. So we've done random. Now the next one, oh, by the way, and I should say, the cell size has an influence on all of these things. So cell size has an influence on a few things. Performance, because the more cells you have, the more velocity vectors or vectors you have being created, and the heavier it can get. Just like with any of these things, the more you increase cells or voxels or decrease their size, they tend to get heavier. Like I said though, and you can see I've just halved that, so it's double the amount. If I go to our vector display and turn off that vector display, the performance returns pretty quick. So the performance is being limited by the displaying of those vectors. So well worth unchecking that if you're seeing performance degradation. But we can see immediately that the curling and everything is much more detailed. Like it's much more detailed because we've reduced the the space between each of these vectors. So if I go back up to 40, it's much smoother, and we don't have as much detail. Okay, that's going to be important for our next one actually, because we're going to be looking at the shaders. So I'm going to chuck our display back on just because I think it's useful to see it when you're learning about this, just to understand how the vectors behave with these different field modes. Okay, go back to general. And we're going to have a look at our next one, and that is shader. Now, shader is going to take a shader from C4D, whether it be a noise, gradient, something like that, and then it's going to apply the black and white changes to these vectors. So essentially, if it's black, it's going to be, as it transitions from black to white, that's where the vector will point. Or at least that's how I'm assuming that's how that works, because this is how it reacts. And you can see here, when I add a noise shader, this is pretty much the best one to use. I would say noise shader is the best one to use with this. And that's pretty much the only one I've ever used with it. And I'm going to animate this noise. And to check that it's animating, I'm going to right click and you can see animate noise. And you can see it's flowing like that. I'm going to increase the scale a bit. And you can see our field responds when I change the scale. Go back up. And now, if I just press play now, the particles are just going to move through this noise field. And you can see it's sort of representing the noise texture. So if I move it back a little bit so we get a bit more influence. There we go. And of course we can change the velocity. We can make it very strictly follow this noise field, or a bit more gentle, and it looks cool. But it's not animating, so it's not changing over time, the noise field itself. And this is where this comes in better than the random, is that you can actually animate this. So if I click animate flow, you can see as the noise evolves, and you can see it, this is the animated preview of the texture, so does the noise field. And you can see how fun that is. It's sort of hypnotic watching the vectors sort of drifting and flowing. So this is like, it's almost like we've just created a really advanced turbulence modifier, except with a few more controls. And so I could try another one. So say we use cell Voronoi. If I pause, so we can see this. You can see this is going, these are very strict boundary color changes. So the change from dark to light or light to dark is very abrupt. And let's see if that's represented when I press play. So we'll see them going in one direction, then all of a sudden they're strictly moved into another direction. And that's because it's changing into another cell, into a 3D sort of zone of the noise. So that's what this one's a lot of fun. And of course you can just play with all the different ones you like, get different responses out of them. You can see this one's very sort of aggressive. And you'll notice that these are jittering. So these are quite aggressively jittering, and it depends on what scale your noise is. If I press pause, we'll see which one it is. And you can see these have much smaller detail in them. We could, of course, reduce the octaves, and it would be a bit smoother and less abrupt. Oh, you can see it actually doesn't even escape that one. But if you want a bit more interesting, you'll add more octaves to the noise, a bit more detail to the noise. Maybe scale it down. There we go. And of course, we can increase the resolution by going to the cell size. Let's turn off our vector display again. And there we go. We get this very nice looking movement through. And we can influence the direction if we rotate the box and things like that. Or rotate the field. Brilliant. Really enjoy that one. And I would say you can use flat textures with this, or non-animated textures. It's just you're going to get a much less interesting result. But well worth exploring that one, the shader one. So let's have a look at our next one. Let's reset our grid. I mean, we can just click reset to default, and we'll return to our defaults. I'm just going to put our 2 vector display back on. Maybe we drop our transparency down on those. The length to the maximum. We're going to change it to target mode. And you can see here, we have target, and it's set to direction. And we actually don't see anything going on because we have no target set. And a target is purely the axis of an object. So if I just chuck a random object in, let's go for a platonic. Do like C4D's platonic. Put that into other objects, and I'm going to click the flow field, and I can pick this. I could either pick it here, I could pick it in the viewport, and you'll see it assigns. Immediately, you'll see that we have the vectors are all pointing towards our target. So essentially, we're making this object into an attractor. So let's just reduce the vector displays down a little bit, otherwise they're a bit extreme. And you'll notice we're in direction mode because I set everything to default, and we need to add a velocity. So let's go back to our general tab. velocity 10%, and we've got a lot of particles being emitted, so I should probably reduce those down. Actually, let's just turn the trail off. That's going to be quicker. And there we go. We can see them being attracted or targeting this object over here, and it's very much like having an attractor in the velocity mode. And we can change this, of course, to acceleration, so they accelerate towards it. And with this, they won't actually hit the target. They'll accelerate, and then they'll come back again. And you'll see them come back towards the target, and it's a bit more organic. That's kind of fun. You can see there we're creating this sort of interesting field. And we can have fall off as well. So there's an option here where we have this cell strength. It's constant at the moment, and also the strength is falling off. So the cell strength is how strong these will be the closer they get to the object. So the actual value, whether it's acceleration, velocity, or direction, will be applied increasingly strongly as it gets closer to the object. And we can actually have proper fall off as well. So strength fall off. Let's put it to linear, and you can see we get this visual representation of the fall off. And as you can see, none of the cells are being influenced here. If I move it into the field or the fall off area, there we go. Okay, that's a pretty simple one, but it just allows you a bit more control over your target. And yeah, I rarely use that one because I quite like how the attractor works. But it's just, the point with this is that you can layer these flow fields up. Just to show you that, actually, I'm going to just control drag that one, and I'm going to reset this to default. So we've now got two flow fields, and you can see if I move this one away, it's different. In fact, I can actually color this flow field. So if I go, let's make it a blue color. You can see I can actually see the outline is now blue, just to see the difference. And we could also change, of course, the vector display to something blue. Or maybe blue-green, something like that. Just so that we've got a bit of difference. And then we could make this one, let's say that we make this one random. Like so. And if I press play now, the particles are going to be, because it's direction only mode, they're going to be pointing in that direction. But if I bring this into the field, you can see I can attract them and also have them moving through that random field, giving them some kind of turbulence look, or curl noise, pretty much. Okay, so yeah, they work together. But if you use velocity in this one as well, it can kind of overtake everything, and you can see it sort of ignores the target. It's not completely ignoring it. It will have some influence, but then this second random flow field is dominating the flow. Okay, so that's pretty cool. I like the target one. It's quite simple. What's up next is even more interesting, I would suggest, and that is the along spline. Okay, so we're obviously going to need a spline, and as this describes, a long spline will have our vectors follow along a spline. So let's have a look at the right viewport, and let's get our sketch pen tool out, and let's make the stroke smoothing nice and high, and let's just go for something fairly straightforward. Okay, and we'll adapt this a bit later because I need to demonstrate something else based on these. There we go. We can have it coming back on itself a little bit here. Just have them a little bit less equal directions. Okay, so we actually need to make sure this is assigned, and so we can either pick it or we could even drag it. Actually, let's drag it in, and immediately you'll see that the direction of the velocity vectors, or the vectors, follow the spline now. But obviously we'll get out of the bounds of the flow field, so we need to expand the flow field, and you can see the vectors update in real time, which is fantastic. There we go. And let's put our emitter closer to the end of the spline just so we can see this happening. And something else you'll notice is there is actually fall off going on. So if I go to our flow field, we'll see this fall off option. If I turn it off and we look in the side view, you can see that's having an influence on every single cell beyond the bounds of the actual spline itself. So you need to work out whether you want fall off or not. If I press play without the fall off on, you'll see some of the particles don't get captured, and the particles can actually escape from the spline, but they are generally following it. If I turn the fall off, every single particle, no matter where it is in the grid, will be moved. So if I actually create another emitter, put it down here, you'll see it follows the spline as well. And you can see already some serious potential with this. There's some really cool things you can do. You're essentially creating your own follow spline, except with this you can kind of balance out the force of it, really sort of tweak how it moves through the field. And obviously if we hide the field, that sort of gives the illusion that this is all free and outside its cell. Okay, so that, get rid of that one. And let's put the fall off back on. Now the fall off just gives us, oh, I need the display back on as well. You can see as I increase the fall off, let's change the display, make sure it's nice and obvious. As I increase and decrease the fall off, the strength in each cell moving away, like in a radius around the spline, increases. And we could increase the strength, and if I press play, most of those particles are getting caught, but it does allow some to escape or just to move away. So that gives it a bit more of an organic look. If I change this to direction mode, of course we need to actually apply some speed to our particles. And if I go to emission, give them some speed. There we go, that's our particle speed. And we can have this, obviously we can have variation in the speed. And you start to see we get this really nice looking organic flow of particles. I've just slowed them right down actually. No, that's good actually. That's a good spread of particle speeds there. And we can actually modify this spline in real time as well, which is really fun to do. So let's do that. You can see wherever the spline is inside the cells, it's actually influencing them. You can see here we're getting quite a sharp turn there. Now if there's a lot of detail in this spline, so if I make this really tight here and I give it some extra sort of tiny little loop-the-loops, you'll notice even if I drop the emitter down a bit, just so it's perfectly following the spline, it's not being pulled down into this area. Mostly because the particles, I probably need to shrink the emitter a little bit, maybe. There we go. It's actually getting caught because the cells aren't small enough, sorry. They're actually jumping across to this next. It's ignoring this whole little bit of detail. So to fix that, you need to reduce the cell size. So let's reduce the cell size. And of course, like I told you, performance drops quite significantly if you're still displaying. And I turn the display off. We should be getting more detail in the simulation. However, I think I've got this aligned a little bit too low, and I need to make sure this is quite heavily influenced. There we go. And you can see some of the particles are now being grabbed by this bit of detail. But you'll find you'll need to tweak this quite a lot, and you'll find some interesting settings. And you can see they're being pulled up higher. If I make it lower here, you'll see it'll get caught by the lower part of the spline. And you can see they are being expressed, that deep bit of detail there. But you can see there's some serious potential here. Obviously our spline's 2D by the way at the moment as well. I can obviously make sure this is going out of whack a bit. There we go, and the particles will follow the spline. Really beautiful effects, and I find this way more organic than using the follow spline, even though that's really cool. And also the new spline flow. This is a bit like using spline flow actually, which is really great fun as well. But I really enjoy this. So what other modes have we got when we're using a spline? We also have a couple more modes. We have a long spline and we have two spline. So if I tell you what, I might duplicate this hierarchy so that we can keep this one. Let's call this one a long spline. Spelt wrong, of course. Duplicate that, turn all those off, and then we'll call this one two spline, just so that we can see what the difference between those is. Let's go to our flow field. Now we can just change it to the flow mode to two spline. Now I'm going to put the emitter up above this time, and I'm going to make it a rectangle, and I'm going to make it long like that, or wide, maybe wide like that. That's kind of cool. Now if we look at the flow field, and I'm going to increase the cells again, give it the fall off. Now what we're having here is the vectors. If we go into one part of the spline, you can see the vectors are actually pointing towards the spline. So you can see this one's pointing towards it, this one, and so on. And then we've got that bit of fall off. So if I press play now, our particles might not make it. Oh yeah, they do, that's fine. Heavily influenced there a bit by the direction. This essentially acts as an attractor towards the spline. That's a little bit hectic. It's a bit hard to it's a bit hard to follow that, isn't it? So let's reduce the width there. And they're getting flung off in all directions because of the fall off. Let's have it really heavily influenced. There we go. And you can see we get these capture moments where things get caught in these little spirals. But you get the idea. We actually attract towards the spline. And I should say we can also use multiple splines. So let's throw in a rectangle. Let's throw in a circle. And what else should we throw in there? Maybe a star. They don't have to be perfectly aligned, but it's fine. I'm going to turn off this other spline. Get a nice, interesting explosion look there. And it's still being influenced, by the way, by the center of the spline. I'm going to grab all of these, pick that one, and that one. Let's just make sure we've got all of them in there. Yep. And let's go back to the beginning. And you can see that our influence is going on. Have I actually got that outside? Oh, interesting. It's actually off-centered. Let's see what happens when we play. Ha! Yeah, so we're actually getting the splines doing some kind of crazy stuff when we combine them there. Let's try turning the fall off. There we go. So interestingly, it's actually pushing the vectors towards this rectangle, but it's actually pushing it towards the back. You get some really interesting effects there, look. Kind of getting this looping around at the very back of the velocity field. But you can move them around, you can do all sorts of fun stuff. I've got a good demo of one of these in another down here. And this is really this is showing how it can be really very cool in motion graphics. So I've got a type object. So let's expand this down. So we've got a flow field that's set to a long spline. It's got a velocity, and we're using the text object, this thing here, as our input for our vectors. Excellent. So what else am I doing? I've got an emitter here that's actually emitting from the edges of the spline, and if I press play, we see something really cool happening. Let's hide our field. Let's hide our original text. And you can see these beautiful fields start to form around the text. And it's only in one axis at the moment. But if we wanted it to go off in different axes, we could make the particles to go off in a random direction to start. But I just wanted to show you there that you can use anything as input. And I could also just emit. You don't have to emit the particles in that fashion on the spline. You could also emit them as a rectangle. Oh, I need to change it to rectangle mode here. Searching around there. It's in shot mode, by the way, so it'll shoot 1,000 out. And you can see if we just do a grid in general, we get these. So these aren't in the fall off. You can see these particles aren't falling in the fall off, and these ones have escaped outside the bounds. But yeah, I really enjoy the flow field with splines. It's actually really good fun. Okay, so what's up next? Next up, we're going to look at flow fields, and let's duplicate this one. We can use this one as our base. Let's clear out all the junk. We can just reset our flow field, actually. That's the quick and easy way to do it. And I'm just going to reset the position so it's at 0. And let's reset the position of our emitter. Make it somewhat default. There we go. Now we're going to go to our flow field. We should change this to nothing for a minute, and then we can decide on a name later. Give it a unique color. Just scene organization stuff, right? We've been dealing with this quite a bit recently. It's where the system object is awesome. Okay, so back in our flow field, and also back to the point. I'm going to change the flow to surface tangent. Now this is really awesome. So I'm going to grab let's grab a torus. This is always good for showing geometry around. I have some more complex geometry that I'm going to bring in. That's a bit more interesting in a bit. Let's make sure we can see the actual polygons. Now what I did there, because this is a parametric object, I can actually view it in isopalm mode, and that's shortcut is NI. So N, then I. And then if you want you can see I'm actually not seeing the polygons there. I wanted to see the polygons, so I hit N, then H. And you can also find those up in the display options up here. So you've got wireframe and isopalms was what I was just flicking between. And I'll show you why that's important in a second. First up, let's set up our flow field, make sure our objects are associated. So drag our torus into the object field, and immediately our vector display changes. And let's have max length maximum, transparency 0, and let's go for a 2-color gradient. Okay, and of course, like I said, we can change those colors at any time we want, but I tend to keep them at default just so I can quickly see them. Now I'm also going to reduce the height because I don't think we need as much height and kind of fit around our object a little bit better. Maybe give it a bit more space around here and here. And then maybe we drop the resolution down, or increase the resolution, drop the voxel size down. So what are we seeing here? Now we're used to seeing these velocity vectors. What we haven't seen before is them in relation to tangents, or related to the normals of the object. Now the normals of the object, even though we're in tangent mode, I'll show you what I mean by normals. So in our options, sorry, in our, I think it is in our options, there we go. We're going to view our polygon normals. So when I select a polygon, we can actually see its normal. Now I'm in tangent mode right now. So if I click on the flow field and I change it to surface normal, because these are both fairly well related, you can see we're actually facing away from the normals. So if I click there, you can see these tangents are facing away from the normals of the geometry. And if there's more than one, it'll kind of blend between them. So you can see this is sort of a blend between these here. A tangent is essentially how this object is put together, the polygon order and the normals that come off them. It's a perpendicular line away from the normal. So it's along the surface. It's like an average along there away from the normal. So it's 90 degrees from the normal, and it points all over the place. And in fact, this is quite a good way of visualizing it, to be honest. So we've got that. I've now got it into normals mode. So this is just one of the 2 surface modes. And I could just bring the particles into the field. So I could actually emit them into it. And you can see what happens is as they get closer, they get repelled by the object. Obviously, maybe that's not the desirable effect. Maybe we want it to attract towards instead of away. So what we could do is we go to the flow field and we can just invert the normal direction. And you can see there, it starts to wrap round and attract the particles towards the surface. That looks really awesome. And also you can tell we've got fall off because not all the particles are being given a direction. So if I turn that off, let's hide our vectors because that's getting a bit aggressive. And there we go. You can see it sort of rotating around along here. Now if I make this emitter a lot wider, I can turn off the trails really as well. You can see that it's representing, it's sort of flowing around it's really cool actually, flowing around the torus there, almost like a sort of a magnetic field. And you can definitely create that kind of thing because all a magnetic field is a bunch of these vectors pointing in sort of conflicting directions and these flows. So that's pretty cool. That is sort of one way of using the surface direction in the flow field, but it's really cool when you emit from the surface itself. So if I actually emit from the surface, if I press play now, we're just going to get this, what I just described, sort of magnetic field almost. Oh, by the way, I've actually activated the limit by accident there. I've just realized that's why it wasn't going in all directions. And you can see here, we're actually getting this. Let's put the trails back on because they look cool. You can see as it's emitting off the torus, we're actually getting this really cool looking flow field. Now, what's really cool is tangent. So let's go back here and let's go to tangent mode. It's the one above. I don't want to invert it because I'm leaving it default. And if I press play, now the surface tangents are a bit more organic looking. So they're kind of all over the place. Where it really shines is when you actually fix the particles to the surface. So you keep the particles constrained to the surface. And of course, we have a nice modifier for that. Follow surface. I'm going to hold shift when I click it, and it goes into the modifier stack there. So I'm going to drag our torus into the follow surface mod, and I need to slow everything down dramatically. So actually, instead of using direction mode, I'm going to use a velocity mode, and I'm going to make it really low. In fact, I'm going to take all the speed off the emitter because currently it's flying around way too fast. And here we go. Also, the particles are a bit large. There we go. And you can see we get these beautiful sort of flows around the surface. And that's looking really cool. And it depends on you know, the geometry. If we reduce this geometry down, if we change certain parts of the geometry, it's gonna affect how these surface normals are gonna work. So if I took this one here, or if I took a set of them and I kind of rotate around like that, we're gonna get some funkiness going on, and the normals will get these little knuckles, I like to call them, where the particles kind of meet and end up sort of spiraling in. So you can see how cool this is and how good this looks, but it looks really, really good when you use some kind of slightly more complex looking geometry. And actually, if I go down to my layer stack here, he's been hiding here all the time, but we have a model, or actually it's from 3dscansagain.com. Brilliant website. And what I've done is I've actually taken it into ZBrush and retopologized it using their awesome Z remesher. And you can see here, he's a lot more complex, of course, than a torus, and you have these polygon flows. So where the tangents are going to meet, you're going to get much more complex sort of geometries and vectors and stuff. So I'm going to associate him with our FlowField. Select our FlowField, drag him into the objects there. Let's show our vectors. Let's also put the fall off back on, just to make it a bit easier to see, to be honest, more than anything. And let's scale our, because we're going to keep it constrained to the surface, we actually don't need the voxels or the field to be much closer, just much further away from the head, I should say. So there we go. And I'm definitely going to increase the resolution of this. So let's go for 20. Let's hide our vectors and make sure our emitter is emitting from our Beethoven bust, and that our follow surface is also attached. There are ways, by the way, to kind of create these setups to be much more efficient. So what we could do is we could have the Beethoven bust in a null, and then we could have Expresso feeding all of these fields, feeding all of these objects into these fields. But honestly, for something this simple, we don't need to be doing that. So let's get to the good part and press play. Make sure everything's working. And there we go. So something's definitely happening. And we can see the particles are kind of moving across the surface. And I'll tell you what, I'm going to turn the trail off for a second. And I think we could probably give it some more speed, right? We could set the strength a bit higher. Let's turn the fall off. We don't need that really. And let's put our trail back on. But we can see now how awesome this is. Can you see how it's following the topology of the object, and the kind of where they meet in these crevices? They're kind of going to get caught because obviously the tangents are all kind of pointing in a sort of a loop direction. But what a great, you know, I love this effect. It's if I hide the bust itself, you can see through here. If I hide the particles even and just leave the trails, you get this really beautiful sort of reveals of objects, almost like you know, like a planetary surface with sort of eddies and all that kind of interesting thing going on, flows. Okay, let's show the bust again. I think it kind of helps us see the surface. So that's the tangent mode. I mean, we can use it with acceleration and direction, so we can apply the speed in different ways. But the main thing is that it takes the geometry and the flow of the geometry, and it will, you can see here, if I actually go into loop mode and select these loops, this is kind of how it's assigning these tangents. So you see where these tangents come together here, there'll be some facing down this way, or have some facing sort of that way, and it just brings them all in. All right, so that's the surface tangent mode. I could show you some really cool stuff kind of with that, endless stuff really. But I'm just going to go back to the surface normal mode just to demonstrate something else really cool, where you can kind of use a cloner to sort of direct your particles or to control your particles. How cool is that, by the way? Where it kind of meets his hair. Very cool. Anyway, so let's get rid of him. In fact, we could create a new system for this. This is probably easier to do. So I'm going to call this surface tangent if we ever want to come back to it. Disable everything. And let's hide him. There we go. Let's add a new system. Do the usual. Turn all the modifiers off. creating a new emitter. And this emitter, I'm actually going to have it coming off a cloner. So let's actually set up what we're going to set up in terms of clones. So I'm going to create a cloner, and I'm going to create it in a honeycomb array, and I'm going to drop some cylinders in here. I'm going to turn the caps off because I don't want any geometry on the caps. I just want the radial geometry off these. So I'm going to make them a bit flatter like that. And I'm also going to make them Z+ because I want them to be facing like that. Perfect. Scale the whole thing down. Let's go into a wireframe just so we can see a bit clearer. There we go. I can make these even smaller actually. I could make these really, really tiny. Something like that. And let's chuck a FlowField in. This will all become apparent what I'm doing in a second. So FlowField. And I'm going to keep it on pretty much one plane because if you think about the normals of these objects, if I actually take one of these, take it out of the system, make it editable, and I select all the polygons and frame it, obviously there's no direction going to happen anywhere outside this X and Y. It's only ever going to be constrained to the Z+ plane or Z plane. Delete that. So I can actually make the FlowField really thin. There we go. And let's make it much higher res. Expand that out there. All right, now I'm going to associate our cloner with the FlowField. But what we might need to do is we might need to drop this to make the cloner, sorry, the FlowField see this as all one piece of geometry. We might need to put it in a connect object. I haven't actually checked that recently, so let's just go from default to surface normal. Drag our cloner in. And no, it's no problem. It connects it automatically within this field, which is fantastic. And then I'm going to drop that even higher. I'm going to make that even higher res. And you can start to see what I'm going for here. Or hopefully. And then I'm also going to add the emitter. Make it object mode, cloner, and then I'm going to make sure it's connecting the objects. Because if it doesn't connect the objects, the emissions occur at different points. And also, whilst we've got that, let's add a trail object. Put him in generators. And let's press play. So you can see, obviously, it's going way too fast right now. So let's set it to velocity, set it to 20, but make sure it's 100% because I want it to really influence these particles. And there we go. We can start to see what's going on here. And actually, that's too much, isn't it? Clearly too much. There we go. So as we're emitting the particles, all of these vectors are merging or blending with each other. There's sort of a fall off between them. And we're getting this really beautiful looking sort of geometric emissions. So I love playing with this because there's so many options here. If we go back to tangents as well, tangents will probably actually throw it off in one direction. Oh no, that's even better. There we go, we're getting these nice spirals. Probably way too hard again. Go back to velocity. Now velocity, you'll notice velocity is much more controlled than direction because we're not relying on the particle speed. So I tend to be using velocity for these particular ones. There we go, we're getting this really interesting looking thing. But as I said before, we're getting these escapees here. So might not be desirable to do that. And of course we can change the structure of the emission. So if I say 40 by 40, or sorry, go into just a standard grid array. Don't need any in Z. And maybe per step, let's do 60. And then we press play. And so it depends on what your source geometry is or what your source grid is, but there's infinite ways of messing around with the surface stuff. So I'm going to actually make the grid much thicker. I'm going to turn the vector display off because that's the only thing that's killing our performance there. Press play, and you'll start to see some really interesting structures forming. You'll see they're pretty similar because we're emitting them in the same aligned with the grid sort of thing. Too many particles, I would say. Drop them right down, press play, and yeah, we get this really interesting looking FlowField. And it'll meet with the other ones, and you'll see it'll kind of wrap round. I need to extend the timeline a bit, but you get the idea. So yeah, input geometry, as with the when I was in the other earlier projects, we were talking about how important the input geometry is. Well, it's the same for the flow field. You know, how your geometry is structured, if you've got it in the grid, if it's aligned with the grid, if it's actually, you know, inside perfectly at the center of a cell, that has an effect, and all sorts of things like that. And also the same goes for splines as well, of course. All right, so that's the surface modes, and just I recommend combining it with the other modes and just playing with it because it's really fantastic. Okay, next up we're going to look at particles. So let's disable this one. I can just get rid of that one, to be honest. And now we're going to take a look at particles as our source for our flow field. Now, what does that mean? That means that we can actually input an emitter and have that drive our vector field, which is incredibly powerful because you can have a simulation going on with all these different modifiers. You could cache it, and then you could put this emitter into the flow field and have it drive other particles. So you're essentially creating an incredibly custom modifier. Okay, so first of all, I'm going to add a new system. Let's go up here to XP system. Do the usual. Of course, I would be better off setting a default, but I wanted to keep things default here just so that you guys can follow along easier. So create an emitter. And in this case, we're going to actually need two emitters. So we're going to have one that's going to be driving the simulation and one that's going to be actually driven by it. So I'm going to turn that one off, duplicate it. Let's call this one FlowField. And let's change its color so we can identify them a bit quicker. So let's change the icon to a yellow. And let's have the color driven by that icon color as well. Press play. There we go, that's fine. Now we need, of course, to add a flow field. So flow field. And we're going to change it to particle mode. Let's set up our vectors first. Let's drop the transparency, 2 color vectors. And because our particles are the yellow color, maybe we should change the color of this thing. So let's do a blue and a green. There we go. Just a bit for clarity. There we go. And let the max length be 100 because I quite like it when it's allowed to be full length. General. We're going to change the flow mode to particles. Okay, so let's drag our flow field particles in there. And to start with, we see nothing happening. And the reason for that is that we're in direction mode, and all we'd be seeing is the direction of the vectors instead of the velocity. So I'm going to change this actually to velocity mode. So it's actually going to take into account the velocity of the particles. And I'm also going to have the particles, the other things being set by this. And I should say that once this is associated with the flow field, you don't need to exclude it. It automatically is inbuilt. And actually, I'm going to leave the other emitter off just so we can see what's going on. So if I press play now, you'll see as the particles emit, the direction of the vectors follows the particle flow. So if I move this around, we start to see some really cool stuff. Maybe I was a bit overzealous with the length of the vectors there. It's a bit ridiculous. There we go. They can exceed their, because we're looking at velocities that go beyond, we're actually seeing the strength of the, so if I actually turn off velocity strength, we'll only see the direction. But it's well worth having that on in our case. So yeah, you can see as I could animate this, I could have it rotating like this. That's pretty cool and pretty interesting. Or we could have it just moving through sideways, something like that, so it only affects parts of the field, and you kind of get these sort of star field, flow field areas. Let's put that over there. But what if let's do a spherical one. That's kind of a bit more fun. So let's make it a sphere, and then it's random, you can see. And I think it is actually getting influenced by the flow field. So if we need to exclude the flow field from influencing this original emitter, you just drag it into particle modifiers, just as you would any other one. And away they go. To see our particles a bit clearer, by the way, we should probably have them as lines. There we go. And obviously those velocity vectors are extremely obnoxious at the moment. So there you go. But you can see how powerful this can potentially be. You know, we can have the particles moving around inside this space, but we're not actually seeing it do anything at the moment. We're actually just seeing it generate the field. So I'm going to hide our particles. I'm going to actually turn our vectors off. And I'm going to turn our emitter on. And this emitter We should probably set this up a little bit nicer. Let's do lines. Or arrows actually is quite good looking on this. And you'll notice they're not tangential, so we need to go to extended data, use rotation, tangential. And if I go to the display tab, and let's do gradient parameter, and I'm going to do a direction one. That's kind of fun. There we go. As you see, they sort of move through different spaces. Let's just grab a different color. Same gradient as I've always been using. And you can see here that as I move it through the field, the influence is firing off the particles, but it's based off these particles. So this is why this is really excellent. So I can move this around and it becomes almost like a repelling force. I could go back to change it to a circle shape, and you'll see that the particles, I can kind of use it almost like it's a wind modifier almost. It's sort of pushing them out the way. And yeah, the possibilities with this one are particularly fantastic, I have to say. There we go. Okay, and if we used a defined emission, we can actually kind of create some more sort of geometric stuff. So if I did a circular, have it maybe go radially, so make sure radial's checked on, and not on non-static mode, so that we can actually have it. There we go. As you can see, as I get the emitter in here, they're going to fly off in those directions. Although because we've got fall off, it's not capturing everything. So go back to general. Oh, let's display our vectors. You can see they're kind of they've got fall off. If I actually increase the fall off, there we go. They're getting caught and sent off in all different directions. It's getting a little bit hard to see, I appreciate. Hide our particles. There we go. So that's a really fantastic way of kind of controlling your particles using another particle emitter. And of course, there are tons of other things we can do here. We could turn the strength really high, so that as soon as they hit a field, they are fired off in the direction of the particles. Or we could have them. We could turn the fall off, of course, and have it immediately affect them. We could also, we could take a look at the smoothing parameter actually. The smoothing parameter is not going to be very visible here, but essentially what this does is it will, the way the vectors are sort of moving, if the particles are changing direction, if these particular ones are changing direction a lot, it smooths out that transition. Very cool. So actually I think when you animate these is when they get really interesting. Awesome. Not the most glamorous example there, of course, but you guys will definitely enjoy exploring the FlowField. And that actually gets us to the end. There's obviously one more mode, which is none, but obviously we don't need to worry about that one. That's just a way of turning it off by driving it as an action. There is a few other things. You can use different groups. You can actually map these parameters. So you can map the strength of the field to the age of the particles and that kind of stuff. So say you've got particles entering the field, you only want the flow field to affect them as they get older. That kind of stuff is all the same as all the other modifiers. Fall off, of course. We have this one called import and export. This is a very specific use case, and I think it's just Unreal Engine, or I'm sure there's other things that use it. But there's this FGA, which stands for, I think it's Fluid Grid, maybe Fluid Grid ASCII or something like that. But what it is it's an exchange format to put these flow fields for the particle systems in Unreal Engine. So if you need to save those out, you just give it a name, you export it, and then you can import it into Unreal Engine. And vice versa, you can load it as well. So that's pretty cool if you're into game development. And special effects inside that. So yeah, this is the FlowField, and I hope this is sort of a good introduction to it, because there's no way I could show you every combination of settings, but I think this is a good start for you guys to get going on it. And I love this. I absolutely love this new feature. I think it's brilliant. And I use it all the time especially with geometry. It's really fantastic with geometry, as we saw before, where you can kind of have it follow the geometry follow the surface and flow over the object way more organically than we've ever been able to do before. Okay, so we're going to take a look at some more of the dynamics coming up next.